Hi everyone, my name is Ian. I'm from Google Research. I'm going to give you a summary about PnG BERT. So let's start from an example about the motivation on this BERT. Here are the two versions of TTS synthesis audio for same input test. Let's listen to the first version.
To cancel the payment, press 1, or to continue 2.
You may feel confused about what it means in the ending part. Let's listen to the second version.
To cancel the payment, press 1, or to continue 2.
You might get a better idea now. So the content corresponding to those two audios are the text in black here. And the major difference between the two versions of audio is the length of the pause at the last comma before 2. So the first model is kind of confused the comma TW2 by comma TOO2, which the pattern used much more frequently in daily English. And the reason is this model takes only phone names as input. So it's very difficult for the model to know whether it's TWO or TOO. We actually saw a lot of similar cases in our TTS research. So we took two approaches for addressing this issue. The first one is, instead of taking only phone names as input to the neural TTS model, we take both phone names and graphemes as input. And secondly, we pre-train the model in a self-supervised manner on a large plain text corpus. The figure here shows the model architecture of PnG BERT. At a high level, it's very similar to a regular BERT, with a major difference lies in the input data format. So the input to PnG BERT is a sequence composed of two segments. The first segment is phonemes, and the second segments are graphemes. Besides that, we also fit in the word level alignment between phonemes and graphemes. The primary pre-training objective is a math memory model. One trick here is the math chain is done at the word level and consistently between phoneme and grapheme segments. There is a secondary pre-training objective, which is language classification. And this objective is only used for pre-training a multilingual PnG BERT. It's straightforward to use PnG BERT as an encoder in the typical TTS model for either attention-based models such as Type-2 or duration-based models such as fast speech or non-attentive capture. Basically, the PnG BERT output of the phoneme positions is used as an input to downstream components. In the experiments, we show that the PnG net outperforms regular net in naturally evaluation, with the wins primarily coming from better processing. We also conduct side-by-side between TTS synthetic audio versus human recordings on 10 speakers. And the result is neutral, which is a great achievement. If you're interested with more about this work, please join us in the remote discussion in the conference. Thank you.